Okay, so now I'm going to get into lesson 6, managing backup and recovery for RAC. And this lesson doesn't focus on fundamental information of a backup and recovery. And instead, we will more discuss on RAC backup and recovery considerations in this lesson. And I will actually split this lesson into two. The first section will be very short, and I will introduce RAC instance topic. RAC instance recovery topic. RAC instance recovery is slightly different from single instance recovery scenario. So I will give you a conceptual idea of an instance recovery in RAC environment. And the second part of this lesson will be media recovery concepts and configuration in RAC environment. And after completing this lesson, you should be able to configure the following items. So you should be able to use archive logo mode, and you should be able to configure faster recovery area in RAC environment, and also use RMAN for RAC environment. So this is an objective. Okay, so instance recovery and RAC. When you're looking at this slide, and you see two different sections, and the first scenario above is number one, remaster NQ resources as a part of an instance recovery in RAC environment, and remaster cache resources and use information for other caches, and LMS recovers GRD. So what does that mean? So we haven't covered this topic yet. We will have to get into cache management, NQ management in lesson 7. So one thing what we can see from here is, during the instance of recovery in RAC environment, we needed some more operation to complete instance recovery. So actually, our scenario above is a RAC metadata recovery process. And background process called LMS process, it recovers global resource directory object. And then S1 process recovers database and build recovery set and resource claim and rolling forward the recovery set. S1 process does perform two-path instance recovery, meaning that S1 process access to the failed instance online redo log file twice. The first time to identify blocks to be recovered, and second time to apply redo to recover identified blocks. So that's by an S1 process. As part of instance recovery time in RAC environment, as you can see in step number 1, 2, 3, 4, at some point your database is not available. Okay, but it's a very, very short amount of time. It could be less than 1 second. Okay, because of internal process during the instance recovery time, your database will not be available just for temporary, just for 1 or 2 seconds. Okay, and then your database will be available after completing instance recovery. Okay, even though during the instance recovery time your database will not be available, but that's in only a very short amount of time. So during the normal time, your database up and running, and then each instance will send the ping messages and heartbeat messages to other peer instances. And if one of the instances goes down, then your database only partially available. So in order to redistribute RAC metadata, we will have to recover global resource directory. That time, your database is not available. So at this time, you may have confusion because we haven't discussed about global resource directory and also global cache service and global NQ service. That's what we have to discuss. And what we're going to do here is I will give you instance recovery concept from my diagram. And this is an example of a two-node RAC database. And in the left-hand side, I have a prod 1 instance. In the right-hand side, we have a prod 2 instance. And also, here we have in the area where RAC metadata is saved. And this area, later on we're going to learn this. This is global resource directory. Okay. So this is a global resource directory, and in the both sides, and both instances have a global resource directory. Okay, and this is a location where RAC metadata information is saved. So we're going to actually make some scenario here. Suppose that I have one database block in the disk. So I'm going to use another one. Let me use this. So we have data block in the disk, and we cached this data block in memory. And then what we did was, as a part of our transaction, we made some change here. Okay. So, user connected to instance 1, for example, and issued the update statement, and data got changed. And at this time, description of this change is recorded in the log buffer. And at commit time, or every 3 seconds, and whenever log buffer is 1/3 full, and log writer writes that information into online redo log file. Let's say we committed this transaction. Now at commit time, Oracle doesn't write dirty blocks to disk. Instead, we only keep description of changes through redo, and that is written to online redo log file. So at this time, your database is out of sync because we committed the transaction, but this is before synchronizing your database. Now, before synchronizing your database, suppose that you had an instance crash. Then what will happen? Now, this is an instance recovery scenario. If this were a single instance scenario, then what happened is, we as administrator, we shut down database instance cleanly and restart up database. So when you restart, SMON process identifies blocks to be recovered and automatically roll forward and roll backward to recover instance. So instance recovery time include startup time and also rolling forward time in the single instance environment. However, in RAG environment, instance recovery time doesn't include restarting a problem instance because that's not what we want to do. During the instance recovery time, what happened is one of the instances in RAG environment will detect instance failure. Okay, because our instances will send network herping messages. So through the herping message transfer, the one of the instances can detect the problem instance. So if a problem instance is detected, and behind the scene, this RAC metadata must be recovered. For example, in this case, we have this much RAC metadata, and this information must be repopulated and must be copied over to another instance. That's internally processed. So this will be done LMS process. Okay, that's by LMS process. And the other one is SMON process running out of instance that is performing instance recovery. It will visit online redo log file owned by problem instance. The first visit is to identify blocks that must be recovered. Okay, so we modified the one block, but we never synchronized. So it was before checkpoint. So if that is the case, what happened is this block, original block from disk will be copied over. Because we identified block to be recovered. And then S1 process will revisit the second time. Okay, we're going to revisit same online read log file, and then we apply this change. Okay, so now this time we have to apply this change, and then we recovered. So S1 process from instance 2 will visit online redo owned by problem instance 2 times. One is the first time is to identify block to be recovered, and second time to apply redo for the identified block or blocks. So that's your instance recovery time. Did I count restarting time of this instance? No. I only cared of the blocks that include the committed transaction. So I want to recover that in the one of the surviving instances. By doing so, in next checkpoint, we can synchronize the database. So that is instance recovery in RAC environment, especially at this time during the metadata synchronization. Your database is not available for temporary, but that's a very short amount of time. But conceptually, it's a good idea to understand the RAC activities, so that way we're going to have a better idea on RAC tuning and RAC activities. We will discuss this topic in lesson 7 and lesson 8 on this area. And then what I'm going to do is I'm going to show you simple demonstration. Okay. So here we have two terminals. And what I'm going to do is, let's see here. I will check S1 process here. So we have ORCL3 instance running out of here. And then what I'm going to do here is SSH. And I will log in as Oracle to host 01. I probably entered the wrong password. Okay. So cd user1 app Oracle product 12. Actually, not this location. Diagnostic RDBMS ORCL 3 trace tail-f alert. So that is my alert location. I'm going to actually check the same thing in the second and third server. Host 02. Okay. And then I will access to host 03. Okay, so what I'm going to do here is I'm going to just kill this S1 process. I killed it. Let's go to this location. So as you can see, instance went down, and instance terminated, and restarted. So look at this, instance recovery, reconfiguration started, list of instance, total 3, and a new instance. So we have actually this kind of information. Look at this. My instance 1, global resource directory frozen, and channel reestablished, and reconfiguration complete. How long did it take? As you can see, instance recovery time actually the metadata recovery time and reconfiguration time, it took 0.2 seconds. Okay, so it doesn't take much of a time. It only takes less than 1 second. So practically this is not really a problem, but it's a good idea to understand conceptual idea. So to discuss this topic, I just showed you a short demonstration. S1 process came back because the clusterware detected a problem instance and restarted. Okay, so let me go back here. So reconfiguration time here is only a short amount of time. If you really want to configure instance recovery time, just like a single instance embodiment. So in the single instance embodiment, we use the fast start MTTR target. Okay, by setting this parameter, we could control instance in recovery time in the single instance embodiment. That includes instance startup time and also instance recovery time. And you can also control same way using fast start MTTR target. You can also control instance recovery time. Okay, so first pass and second pass and recovery of data block identified. And also once you set fast start MTTR target from $v instance recovery, you will see one column, estimated cluster available time. So how long does it take to make cluster available again in case of instance recovery in RAC embodiment. So that's what you can see from here. And also, the small tips here, instance recovery. To reduce instance recovery time, use a parallel instance recovery and set parallel min servers. So at instance startup time, start minimal number of parallel execution servers and use asynchronous I/O to avoid the wait time, and also increase the size of default buffer cache. During the instance recovery time, in the surviving instance, in this instance, large amount of memory space will be allocated as a maximum to recover blocks from problem instance. So sometimes you get better instance recovery time by increasing the size of a default buffer cache. Okay, so this is our first part of this lesson. It was about instance recovery concept.